Hello, everyone. I'm Verde Arbusto, and this is the Schumann Resonance Harmonics channel on Facebook and on YouTube. And thank you all for being here. I appreciate everyone for coming here today. Thank you all. It is September. I'm sorry, no, it's December. What the heck am I talking about? I was working with something that was in September. This is the 12th of December, as it says down here on my monitor, and it's rainy out. It's kind of miserable. It's drizzly. I had to. Sorry, I needed to pause that. So I had to do a video. I have to actually cook a little bit in a little while, so I wanted to do a video of this subject, this information, and post it up because it's relevant to the discussion I've been having already about the Earth as a DC circuit, about grounding, about people, humans as a capacitor, as an inductor, and you as a transducer of energy. And this is an ongoing discussion. It was important yesterday. It's important today. It'll be important tomorrow. Okay. It's what we're working through. I'm trying to keep this general information simple to everyone. And I will say this as an introductory before getting into the material. I generally have a disclaimer, some introduction before the material, and then kind of this is it. That um, it's as we're talking about like ascension symptoms, we're talking about on a physiological sense of your ability to ground out the energies that are around you. And it's important to know how the Earth ionosphere interchange works, and that while it may be true that it's all energy, yes, energy comes in different forms. This is the world of forms. We are embedded in the world of forms. And there are two circuits that are of our concern here, and they're separated by what we live in, right? And so, relative to the Schumann resonances of learning what these energies around us are, it's important to understand how the system works, how the interchange, the exchange of energy between the upper DC circuit and the lower DC circuit works. So, uh, I I love doing live chats. I want to continue doing those. The problem is there's too much. I wind up having too much information that I want to send out on a live stream that I probably should do as a separate video. Um, the wonderful benefit of doing live streams is that I can. Let me turn down my volume here. The wonderful thing that I like about doing live streams is that I can um, chat with people and with the audience members, and specifically those of you who've been around for a while. Now that I have the wonderful ability through OBS, which is free, uh, I can do a video the same thing I can as a live stream. It's different. I've kind of perfected the technology here in such a way with what I have. It's wonderful. So that's the advent of technology. So for the same effort, technological effort of doing one or the other, Wages talks about that of doing the edited video versus the live video, and for whatever his process, his creative technological process, it's different. It's takes longer, to do his edited one than the live one. So, right, there's a difference between the two. There really is, in a number of ways. And so, even if for me that technological barrier isn't in the way, in the same way as him, okay, Uh, for me, doing a live stream is different because I want to chat with the people in the audience and I get sidetracked, you know, through a lot of times even through answering the questions of the basics. And I can't get into the more complicated stuff until I've covered over the basics. And I have said this in the live stream. I'm saying it now. This is more of the my little disclaimer kind of thing here that uh, I get, and I'm even apologetically so. I get sidetracked in doing the live streams because I want to answer the questions of the subscribers, and I want to answer the I want to answer when Alex is in the studio, you know, uh, and I ask, I have what I think is maybe a complicated, kind of complex topic. I throw it out to him. Does that make sense? And we have a dialogue about it. And frequently enough, we'll get sidetracked off onto something else, which is always good. Okay, so the difference between me, you know, Wages has thing of his thing why he likes the edited versus the live, and that's all good. I can perfectly understandable. Um, for me, the difference between the edited and the live is that I get sidetracked off on the live, and I want to answer the questions, and I want to become involved in what people are saying, and so it's that important to me to to interact with people in the live. I have my studio set up exactly here. I'm recording this exactly as how I have it. It looks pretty familiar for those of you who've been around. This is the setup now. The format I'm using. And so as I kind of even more hone it down with little better cameras and whatever, this is what I have produced here. All right. Great looking videos, if I can say so. And I'm looking at the version over here, and it's cropped out a little bit, and the little edges are kind of like taken off, like on you have a notebook paper that you rip it out of the little spiral thing, and there's those little furly edges. Well, the top of the browser is missing from here, so it reminds me of those edges that were taken off. That it's perfect. It's literally perfect now. It's flat. It's level. It's justified, and all you see is just the very top of the um the name of the file here that I have, you know. Um, all right, so that's at 10 minutes into this almost. It's or 9 minutes. It's is my introduction. That serves as a good introduction to the video at large. And let me explain the thumbnail of what you're looking at here. Okay. We're looking at two different circuits. One is the DC circuit of the sun's energy coming right from the sun to the earth and hitting the ionosphere. Now, I'm only using the graphic that was provided in the video that we'll go into in a minute or moment. And so I'm using this. But there's also, as I've spoken about this, there's the magnetosphere that catches a lot of the bigger stuff from the sun. Okay, it catches the majority. I'm just going to say it catches the majority of the the offage, the solar winds, the whatever that is coming from the sun to us. Okay, so I don't put that here, but that's a layer that's there. I've talked about that. All right, so the ionosphere is what is immediately surrounding the Earth. That's what, relative to the sun, immediately underneath the magnetosphere is the ionosphere. So we're talking about here kind of the in our discussion here is largely the interchange of the ionosphere with the Earth's surface. And I kind of dolled this up with a little bit of blue and green as a reminder that the Earth's sphere is largely covered with water, which is somewhat malleable, and it doesn't necessarily reflect the EMF, but it can't, it does excite it up a little bit. All right. So, um, this is also another, uh, our other, this is our AC circuit. Okay. This is the other type of circuit which interacts between. Now, here, it's the same sort of thing of I've dolled this illustration up so you could see. Here's our same water vapor uh, insulating kind of barrier around the immediate Earth, uh, nitrogen, oxygen, and water vapor. It's the planet is surrounded by water, and that's the water vapor figures in there somewhere. So, um, uh, so I'm presenting this as the Schumann resonance complex of measuring, which I'm showing you here. The yellow is mode 2. The white, all of this here, is mode 1 of the Schumann resonances. Okay, and then you have this is brown, but it's the reddish as well of mode 3, and then you have this green of mode 4. Now this isn't quite a red, but this is serving as a double entendre, that I'm using this as representative of the Earth itself, but also as kind of mode 3, okay, which is the red one at Tomsk, right? So the yellow and the white ones here. So all the colors uh, of the Tomsk are represented here, and since a lot of times on the Schumann spectrogram, it's not actually red. We're getting this brownish mud color. That's more of a representative of the the color code on the spectro of Tomsk than the true red. Okay, so if this isn't too complicated, if it's not too complicated or too complex for you, and you're able to follow, please put comments in the below, or the next time I do a live cast, ask me questions about it. Because I as well also keep trying to, part of this show is about explaining how to read the Schumann resonance uh, reports from Tomsk. Okay, so um, that is the big, one of the big deals is how to read the reports of it, not just what the Schumann resonances are, but how to read the reports that are from the detector machines. Okay, so this is a tall order, and I get even a little bit bobbled up with the words even talking about this sometimes, because there's a lot of technical stuff that I have in my head and pictures that I need to put out in words, logical words, for everyone to understand. So a lot of me with doing this is trying to translate a picture into words, logical words for you all to understand. And it's not not always the easiest thing to do. So, all right. So this is the simplest kind of explanation of the graphic I made here. So I should probably do a little bit more explaining of it, but I think what I'm going to do is have this as this video is going to be really an introduction to the live stream, which is probably going to be late tonight. I have to cook and I got, spend some hours doing a few things, but maybe tomorrow, or depending on your time zone, it may be tomorrow. I'm thinking like 11:30 tonight, 11:30 Eastern time. Kind of the same thing I did last night. Maybe an hour before midnight, which is 7, 6, well, like 5, I guess 5 UTC. midnight is 5 UTC. All right. So this this is certainly not going to be a short introductory video. But so one of the things is just, I guess, to summarize or to kind of review what I just said, that I like doing these recorded videos because it lets me get out all the information I need to without being sidetracked. And this gives me a chance to show people, all right, go to that video over there, watch it. Okay. This is important information that needs to be known, that needs to be understood. Okay. So I've been talking about this. I'm jabbering on. I think I feel like a broken record here. I've been talking about this in my live stream about the Earth, the DC circuits, and all of that. And this is important because the next part of this deals with EMI shielding, EMI radiation. EM is electromagnet. EM is electromagnetics. RF is radio frequency. So, in the course of you're in a world surrounded by electrics and electronics that are sending out. We are sending out lots of electronic EMF waves and signals and frequencies. So it's important to know how to be shielded from that. As such, the higher radiation, microwave stuff, it's important to be shielded from that. But the resonances of the planet are a different frequency of our range that are different, that need to be channeled through us. Okay, hopefully that makes sense. All right, so that's one of the topics that I've been kind of discussing is shielding and grounding. Right, shielding yourself and your property, yourself, your electronics from external outside interferences, and yet the Schumann resonances, which are all bouncing around the world, those are for grounding. Okay, you grounding those in through you. All right, so the two different yet complementary processes. I don't know how to explain it better than that. All right, so all right, so hopefully at 19 minutes into this, I haven't been too long-winded. All right, so this is going to have, I'm going to talk about this more on my live stream. This is sort of an introduction. This is a complicated wefting and weaving, as you can see here, but this is starting to kind of show some learning lessons and some points I'm going to be making, I guess, in my live stream. All right, so just as a general understanding of what the illustration is, I have given that. Hopefully, leave a comment if you don't understand it. I needed a visual diagram for this lesson, and so I couldn't find, just between you and me, I couldn't find a good diagram of this, so I had to go with where I knew there was a good graphic, and I don't mean good quality, but a good graphic to show what this circuit is. And so so what I decided to do is I broke out this video from way back when. Okay. And this is a video that I had, this is the original video that I had posted on the Ted Madden memorial. Ted Madden is one of the pioneers of the Schumann Resonances. Okay, they're here in Rhode Island in West Greenwich. I'll get off the topic here for a minute. West Greenwich, there is a Schumann Resonance measuring station. I haven't been to it yet, but the group from MIT, he's one of them, kind of set up the Schumann Resonance station in West Greenwich. Okay, so So Mr. Madden here, he was one of the ones that was instrumental in that, and so that's why part of this, why a big chunk of this is relevant, and I'm still learning. I want to learn more about Ted Madden, and I haven't had the time to. But uh, the what am I going to say? The hold on. The video serves as a review. I've already played this video all the way through. I'm not going to play this video all the way through again. Um, I am going to just play the introduction where he talks about the AC and the DC circuit because, quite honestly, this is a guy that's a professor from MIT that explains this better than I can, I think, and he explains it very well. And so this. Whenever he gave this in 2013, it was relevant then, it's still relevant now. This information is still important, and it's a review. I don't know if anyone had watched that video, so I can very well say, that didn't get a lot of views. So, here it doesn't hurt to review. It never hurts to review. So, this is again and again with the graphic from the thumbnail here that I put up comes from. So I'm going to play this as a review of the Earth as the AC/DC circuit, because the other part of this, the technical part from Springer Link, is technical, and this is this is broken down for easier understanding than the other one, which has technical information and it's less, it's the easier one should go first. So this one here, it's the review, and this is the easier one. And so let's play this.
Okay, Schumann Resonances. We live in a special place. We live in a gaseous medium trapped between a conductive Earth and a conductive ionosphere. And that geometry sets up what we call the global electrical circuit. And there are two global circuits. There's the DC global circuit, which is very simple in concept. It's a giant capacitor, basically. And it's maintained by global electrified weather. And there's about a 250,000 volt potential difference between the conductive Earth and the ionosphere. Very simple concept, but very hard to measure that and monitor it continuously. Then you have a much more complicated phenomenon. We call it the AC global circuit, which is Schumann resonances. And this is it really is a more complicated phenomenon, wave phenomenon. It involves standing waves in the Earth ionosphere cavity. Speed of light, the time it takes light to go around the world is 1/8 of a second, and so the corresponding frequency is 8 cycles per second. That's the fundamental mode of Schumann resonance. And it provides a natural framework for going after global lightning activity. Now, we know a lot about global lightning activity from satellite observations, which see lightning in the optical. We know that there are three main...
Indeed we do. However, that's where we're going to stop. Let me bring my cursor over. There I am. Hello. All right. So that was just that little introduction there. There's way more to it that was important to bring up relative to the go to the video. I posted a link. I kind of pilfered that video and put it on my site because it was important enough to talk about relative to a number of topics in the Schumann resonances. Okay, so just that introduction was what I wanted you to see. Okay, and so thank you all for being here. I appreciate everyone for your love and support. And like, share, subscribe this video, and I hope to see you at my live stream. I don't know if Alex is going to be there. I don't think he is. It's late in the day. I doubt he's going to be coming in. All right. I think he's with his kids tonight. Just in case any of you were wondering about Alex, I think he's with his kids today, or generally speaking, he spends the weekends with his kid. Tries to. So on Saturday, you know, All right, so this is the topic at hand. Okay, it says an overview of Earth's global electric circuit and atmospheric conductivity. Okay, so this is going to be more of a technical kind of explanation of this discussion on the Earth's global electric surface, and this is Michael J. Rycroft. And this is part of the Space Science series of ISSI book. I'm not even sure what that is. All right, um, the text abstract. The Earth's. Let's see if I can do this. There we go. The Earth's global atmospheric electric circuit depends on the. All right, so the Earth's global atmospheric electric circuit, okay, depends on the upper and lower atmospheric boundaries formed by the ionosphere and the planetary surface. Thunderstorms and electrified rain clouds drive a DC current, which is give or take 1 kiloamp, around the circuit, with a circuit carried by molecular cluster ions. Lightning phenomena drive the AC global circuit. The Earth's near surface conductivity ranges from 10 to the negative 7th S. I'm not sure what the S is. I don't think that's a second. Per meter to the negative second, to the negative 1, rather. For poorly conducting rocks, to 10 to the negative second S. I'm not sure what the S is, per meter to the negative first. For clay or wet limestone, with a mean value of 3.2 sm to the negative 1 for the ocean. Air conductivity inside a thundercloud and in fair weather regions depends on location, especially geomagnetic latitude, aerosol pollution, and height, and varies from approximately 10 to the negative 14th s to m meters to the negative first, just above the surface, to 10 to the negative 7th s. Trying to find out what that s is, the capital S. It's not showing me some type of a charge, surface conductivity. All right, so negative to the negative first in the ionosphere at approximately 80 kilometers altitude. Ionospheric conductivity is a tensor quantity due to the geomagnetic field and is determined by parameters such as electron density and electron neutral particle collision frequency. Oh my God, what did I just step in here? And is determined by parameters such as electron density. Okay, I got that. All right. And electron neutral particle collision frequency. Okay. In the current source regions, point discharge, which is coronal currents, play an important role below electrified clouds. And below electrified clouds, the solar wind-magnetosphere dynamo and the unipolar dynamo, due to the terrestrial rotating dipole moment, also apply atmospheric potential differences. Okay. Okay, this is why this was important to read this somewhere outside of the live stream so that I can actually make it through this. All right. Detailed measurements made near the Earth's surface show that Ohm's law relates the vertical electric field and current density to air conductivity. Stratospheric balloon measurements launched from Antarctica confirm that the downward current density is approximately 1 pico amp. I would say it's pico, because I think peto is the capital, PETA is the with the capital T. All right, so I think it's a pico amp to the meter to the negative second under fair weather conditions. So that's millimeters. Okay, a meter to the negative second is pretty sure that's millimeters, not centa. I'm pretty sure it's no, like I said, millimeters under fair weather conditions. So on the talk about fair weather conditions, that's the dark blue of the Schumann resonance chart of the background. All right. Fortuitously, a solar energetic particle (SEP) event arrived at Earth during one such balloon flight, changing the observed atmospheric conductivity and electric fields markedly. All right, so that was solar energetic particle event changed the observed atmospheric conductivity and electric fields markedly. Okay. Recent modeling considers lightning discharge effects on the ionosphere's electric potential, which is plus or minus 250 kilovolts. So 250,000 plus or minus 250,000 volts with respect to Earth's surface. Okay. Recent modeling considers lightning discharge effects from the Earth's, I'm reading this again, from the ionosphere's electric potential, which is plus or minus, as I say, 200 to 250,000 kilovolts with respect to the Earth's surface. And hence, on the fair weather potential gradient, which is typically approximately 130 volts per millimeter close to Earth's surface, we conclude that cloud to ground CG lightning discharges make only a small contribution to the ionospheric potential, and that sprites, namely upward lightning above energetic thunderstorms, only affect the global circuit in a minuscule way. We also investigate the effects of mesoscale convective systems on the global circuit. Okay. So I am mercifully, I think, so not going to go into this. Okay. So I've already read that, the abstract. All right. And then the next one here is where they start talking about the global atmospheric electric circuit. Okay, so I am going to, I think I'm just going to read this first paragraph here. I'm not going to read more of it. The link will be in the description. You can read more of it. I'm at, my time is showing 35 minutes, so like this is long enough to have introduced this. You're probably may likely not be going to look this up yourself, but you listen to me talk about it because you can put it in the background, and you don't have to, you can do something else while listening to this. And so this is why I like doing these, because it gives you a chance to do something else, and you put this in the background, and you'll learn something, subconsciously. Okay, so all right, so the keywords are atmospheric electric circuit, conductivity models, fair weather observations, electrostatic modeling. All right. It says the global atmospheric electric circuit. Okay. And again, I'm just reading this first first section here. All right. So it says the conceptual model of the Earth's global electric circuit has been introduced by Alpin et al. 2008. In brief, I think it makes it harder to see. I'm going to do this. All right. So, in brief, the circuit is formed between the Earth's surface. In brief, the circuit is formed between the Earth's surface, which is a good conductor of electricity. So the surface is a good conductor of electricity, and the ionosphere, a weakly ionized plasma at roughly 80-kilometer altitude. Between them is the atmosphere. This is a reasonably good electrical insulator, i.e., it is a leaky dielectric medium. Electric batteries exist below or inside electrified clouds, i.e., thunderclouds. These cause an electric current to flow up to the ionosphere. The DC, which is direct current electric circuit, is completed by downward currents flowing through the majority of the Earth's ionosphere in the fair weather region remote from thunderstorms and through the rocks and oceans of the Earth's crust. And these folks, Williams, Harrison, Rycroft, Markson, Rycroft et al., and references therein. This is a corresponding AC, which is alternating current circuit in which phenomena are produced by lightning discharges. That's Williams in 2002. Lightning discharges radiate radio signals across the electromagnetic spectrum, the lowest frequencies of which propagate completely around the globe. These standing wave signals at 10 hertz, approximately 10 hertz, excite the resonant cavity formed between the Earth and the ionosphere. These are the so-called Schumann Resonances, which are Schumann in 1952. See that? Schumann, 1952. Details of Schumann resonance phenomena are dealt with by Simones et al. In 2008. Okay, so this becomes why it's relevant to us. All right. So there's a lot of equations here. This is getting into the more advanced stuff that, this is why I don't necessarily want to deal with it, because it's kind of advanced math, a bunch of symbols that aren't numbers anymore. All right. So I think 40 minutes is kind of long enough to have done this video. It's certainly a good introductory. I got 2 for the price of 1. All right, whatever. So, all right. So that's kind of ends the discussion for the day. And what we're talking about is the overview of the Earth's global magnetic circuit. And this is an important discussion. And hey, if I read this, then I bring it to you on my channel as well. So you can have the fun and the joy of wading your way through this. People ask me, how do I know? How am I an expert? I read. This is what I read. You see this. I make my way through it. I fumble my way through it, and as I present this to you, you all learn, and then you kind of help either reinforce what I know or give me, like a direction to travel in of how do I explain this better in some ways. And so before we can talk about kind of grounding, I think, like even though it's an ongoing thing, it's kind of in the grand scheme, the wefting and the weaving, the grand chess game of this. How do how do we talk about grounding? All right, well, let's get back to, the basics. Let's readdress the basics of the Earth and the ionosphere as the DC and the AC currents. And I think a lot of people don't realize this or why it's relevant or how it's relevant. So before me to you can talk about grounding, we're talking about, or grounding or shielding. Either or. How we can talk about that is that you have to understand, some basic principles. And so this is one of those principles that's involved before grounding is the electric circuits, the telluritic circuits of say, the lithosphere, of the ionosphere, and the Earth's different DC circuit. Okay, so thank you all for being here. I appreciate everyone, your comments, your love, your support. Sticking with this, I'm especially grateful and thankful to the universe for giving me the ability to present this. Were it not for you, my subscribers, I wouldn't have had a need for this wonderful, studio that I have, that I'm able to make these for you. So hopefully, we can keep this going. If you like this, support it so I can do more of this. By you supporting me through PayPal and other means, you're allowing me to do more of the Schumann resonance stuff rather than the other job, which is landscaping. Okay, so just remember that as you support me with the PayPal and whatever else, um, I don't have to do moving bags of cement or landscaping or sheetrocking. I can do more, maybe not necessarily longer videos, but more production on different elements of the Schumann resonance. So thank you all for your love and support, and I appreciate your comments, and I appreciate you being here, because it gives me a reason to get up in the morning. I guess that's the best way to say it. Thank you all for being here. I appreciate this very much, and have a wonderful rest of your day. Thank you very much. Namaste.